First question concerns circuit breaker size when using variable speed drives. The answer is yes. You can safely reduce the feeder circuit breaker size to 115% of the input rating of the variable speed drive. Section 430.128 states that the disconnect device for a variable speed drive must have a minimum rating of 115% of the variable speed drive's input, but it does not specify a maximum. Since variable speed drives do not have large inrush currents, the requirement for increased circuit breaker sizes to accommodate inrush is not an issue. The second question addresses disconnect location. Variable speed drives are not considered controllers as defined in the National Electrical Code. Therefore, 430.102 does not apply. However, the disconnect for the motor must still be within sight of the motor, unless the exception for a lockable disconnect is used. So, if you have a lockable circuit breaker serving a variable speed drive without an integral disconnect, you would still need an additional disconnect in front of the variable speed drive. The third question is about integral disconnects. An integral disconnect on the variable speed drive satisfies the requirement for a motor disconnect if it meets the requirements of 430.113, which includes being in sight of the motor. Therefore, an integral disconnect does qualify. The word individual in 430.102 refers to the disconnect serving a single motor, not to a separate device. To reiterate the key points, firstly, circuit breaker sizing for variable speed drives can be reduced to 115% of the input rating because they lack large inrush currents. Secondly, while 430.102 doesn't apply to variable speed drives directly, a motor disconnect is still needed within sight of the motor, unless a lockable disconnect exception is used. Thirdly, an integral disconnect on the variable speed drive qualifies as the required motor disconnect if it meets the requirements of 430.113. In practice, this means carefully considering the specific installation. If the motor is not within sight of the level 2 lockable breaker and variable speed drive, a disconnect on level 3 near the motor is required. This could be a separate disconnect or an integral one within the variable speed drive enclosure, provided it meets the necessary safety standards. When selecting components, always refer to the manufacturer's specifications for both the variable speed drive and the motor to ensure compatibility and compliance with all applicable codes and standards. Remember that the National Electrical Code is a minimum standard, and in many cases, exceeding these requirements can improve safety and reliability. Consider factors like voltage drop, ambient temperature, and future load growth when sizing conductors and overcurrent protection. For example, even though the code permits sizing the circuit breaker at 115% of the variable speed drive input, you may choose to increase it slightly to account for potential harmonics or voltage fluctuations in the system. Similarly, when selecting a disconnect, ensure it is properly rated for the voltage, current, and horsepower of the motor. Look for features like visible blades and lockout/tagout capabilities to enhance safety during maintenance. In summary, proper application of the National Electrical Code, combined with sound engineering judgment, will result in a safe and reliable variable speed drive installation. Always consult with a qualified electrical engineer or inspector to address any specific questions or concerns related to your project. Remember that these guidelines are based on the 2005 NEC, so always refer to the latest edition of the code and any applicable local amendments for the most up-to-date requirements. Also, consider consulting with the variable speed drive manufacturer for specific recommendations regarding overcurrent protection and disconnect sizing. They may have application notes or guidelines that are tailored to their specific products. Furthermore, it's crucial to understand the specific parameters of the motor being controlled by the variable speed drive. The motor's nameplate data, including full load amps, service factor, and thermal protection characteristics, will inform the selection of appropriate overcurrent protection and motor overload protection settings within the variable speed drive. In addition to the National Electrical Code, other standards and regulations may apply to variable speed drive installations depending on the specific application and location. These may include local building codes, environmental regulations, and industry-specific standards. Be sure to research and comply with all applicable requirements to ensure a safe and compliant installation. Finally, always prioritize safety when working with electrical equipment. Follow proper lockout/tagout procedures, wear appropriate personal protective equipment, and consult with qualified personnel when necessary. Electrical work can be dangerous, so it's essential to take all precautions to protect yourself and others. Remember that variable speed drives introduce harmonics into the electrical system, which can potentially affect the performance of other equipment. Consider using harmonic filters or reactors to mitigate these effects, especially in sensitive applications. Harmonic mitigation can improve power quality, reduce equipment heating, and prevent nuisance tripping of circuit breakers. Furthermore, proper grounding is essential for variable speed drive installations. Ensure that the grounding system is properly sized and installed according to the National Electrical Code to provide a low impedance path for fault currents. Grounding helps to protect personnel from electric shock and prevents damage to equipment in the event of a fault. In conclusion, installing a variable speed drive involves careful consideration of several factors, including circuit breaker sizing, disconnect requirements, motor protection, harmonics mitigation, and grounding. By following the National Electrical Code, consulting with qualified professionals, and prioritizing safety, you can ensure a successful and reliable installation. And please remember that electrical codes and standards are subject to change, so it's important to stay up to date with the latest requirements. Regularly review the National Electrical Code and other applicable standards to ensure that your installations are compliant and safe. Keep in mind that the minimum rating for the disconnect is 115%, but that does not prohibit you from using a larger disconnect. The selection of the appropriate size depends on other factors such as ambient temperature, conductor rating, and future load considerations. When sizing the disconnect, also take into account the voltage rating of the disconnect and ensure it matches or exceeds the system voltage. It is generally good practice to choose a disconnect with a higher voltage rating than the system voltage to provide an additional margin of safety. Moreover, the disconnect should be suitable for the intended application and environment. For example, if the disconnect is installed in a corrosive environment, choose a disconnect with a corrosion-resistant enclosure. The interrupting rating of the circuit breaker should be adequate for the available fault current at the point of installation. The available fault current is the maximum current that could flow during a short circuit. The circuit breaker must be able to safely interrupt this current to prevent damage to equipment and injury to personnel. Obtain a short circuit study to determine the available fault current. The motor overload protection provided by the variable speed drive protects the motor from damage due to overcurrent conditions. The variable speed drive monitors the motor current and trips the drive if the current exceeds a preset value for a specified period of time. It is essential to properly configure the motor overload protection settings in the variable speed drive based on the motor nameplate data. The National Electrical Code also requires that the motor be protected from short circuits. This protection is typically provided by the circuit breaker. The circuit breaker should be sized to protect the motor conductors from short circuits, but it should also be small enough to allow the motor to start without tripping the breaker. As previously mentioned, variable speed drives can generate harmonics, which are distortions of the sinusoidal waveform of the alternating current voltage and current. These harmonics can cause various problems, including overheating of equipment, increased energy losses, and interference with communication systems. To mitigate harmonics, consider using harmonic filters or reactors. Harmonic filters are designed to reduce the amplitude of specific harmonics, while reactors help to reduce the overall harmonic distortion. Proper grounding is a critical safety measure for variable speed drive installations. A properly grounded system provides a low impedance path for fault currents, which helps to protect personnel from electric shock and prevent damage to equipment. The grounding system should be designed and installed in accordance with the National Electrical Code requirements. In addition to the National Electrical Code requirements, other standards and guidelines may apply to variable speed drive installations depending on the specific application. For example, the Institute of Electrical and Electronics Engineers provides standards for power quality and harmonic mitigation. It is essential to be familiar with all applicable standards and guidelines to ensure a safe and reliable installation. Lastly, remember that electrical safety is paramount. Always follow safe work practices when working with electrical equipment. De-energize the equipment before working on it, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, seek the assistance of a qualified electrician.